Good day, everybody. We have a problem that's similar to an SMO junior. I don't have the year I lost that. I think it's like 2012 maybe. But again, this problem is similar to an SMO junior problem. I think it was around 2012 maybe. Okay, now we're supposed to find the equation of a line that intersects the graph of the square root function at 2 points, and we're not given the 2 points, but we're given the midpoint. Okay, so the equation of the line I'll be looking for, I guess we'll use, we'll just aim at the standard y, what do they call it, the slope intercept form. It should be called the slope y-intercept form, because when x is equal to 0 you get b. This is a famous form right here. And let's see what we can do with the given conditions here. Now, the very first thing we can do is just use the well-known midpoint formula, where you divide each of the sum of each coordinate by 2, which is the average of two real numbers, which it all makes sense geometrically too if you draw a triangle. But anyway, MP is midpoint, of course, and this is what we get. This is just the given information right here: 89 over 18, 13 over 6 from right here. Okay, and so when you multiply through by 2, you get 89 over 9. And notice that y is the square root of x, so it's important to recognize that y sub 1 is equal to the square root of x sub 1. Y sub 2 is equal to the square root of x sub 2. And y'all, the rest of this is just arithmetic. We're given the information. We know what x1 plus x2 is, and we know what y1 plus y2 is. So these are natural things to do, square away. And once we do that, we get to this point right here. And again, y'all, this is just some arithmetic. You can verify that I've done the calculations correctly. And it's favorable to split 40 over 9 like this, because you see you get two numbers that do sum up to 89 over 18 here. Well, when you multiply by 2. 89 over 9, this is, you get the 89 over 9, and so you do get two numbers that meet the conditions of the problem, this 89 over 9 actually, okay? Now there's other possibilities, but these are the only two possibilities that correspond to the midpoint condition, okay? So, here we go. All of this stuff is fairly routine right here. I calculate the slope first, and then so we can use y. We use x sub 2. The square root of x sub 2 is 5 over 3, so that would be y sub 2. We'll use that one. So we can write down 5 over 3. And this is just the y. Okay, y equals to mx plus b. We know the slope is 3 over 13. Okay, and then the corresponding x coordinate right here would be, again, right here, 25 over 9. And then you get plus b. And again, folks, this is the y equals to, which is concrete numbers in it, mx plus b form right here. Right, that's all this is. Now when you solve this for b, I'll just write out the answer, folks, rather than go through all the arithmetic. When you solve this for b, you end up with, I believe it, let's see here, I wrote it down somewhere. When you solve for b, you get 40 over 39. Okay, and so the final result would be y is equal to 3/13 x plus 40 over 39. And I did double check the arithmetic here, so I'm pretty sure this is all right. So this is what we're looking for right here. Now, sort of a sanity check on this is to note the range of the numbers, you know, like the number of 5/3, the number 25/9. 25/9 is the x-coordinate, so it's somewhere around 3, right? Somewhere around 3. Well, notice this slope here. Now, we know what this, we know that ddx of the square root of x, this is just kind of a sanity check to make sure your numbers are in range of what they should be. This would be, this is very well known from the chain rule, just 1 over 2 root x. Okay, now notice 25/9 is a number fairly close to 2. It's closer to 3 actually. But if you check, well, we can check 2 or 3 if you want. So if you want to check 3 right here, you would get, when you put 3 right here, you get 1 over 2 root 3. Okay. Okay, for the slope at 3. Well, you see, notice this number and this number are fairly close, I think. This is not quite 1/4 right. This is somewhere in that range. So you see these numbers, this slope of this line that's passing through the square root function in a certain neighborhood is approximately numerically the same as what you get when you just take the derivative of the square root of x, which is the slope, within a certain region. Okay, so in other words, these two numbers right here couldn't be too far from each other, I don't think. This number and this number, the slope here at a fixed point, and this is kind of this is just a slope somewhere in the region of this point. Okay, so anyway, that's kind of a check, and you can graph it to see that it all works out. I graphed it at somewhere, I think Desmos, and it looked very nice. It looked like what you would expect as far as relating the midpoint to the graph and the line. Okay, that is the answer, folks. Thanks for viewing.